There are many types of trig integration that you need to know for C4. I'm going to give you some techniques here, but you will need to do more practice of these and plus others in class. I'm just going to start off with a reminder that if you, this circle here, sin x to cos x to minus sin x to minus cos x, if you go around in that direction, that's if you're differentiating. So here we're looking at integration, so you need to go in the opposite direction around the circle. So for example, if we want to integrate cosine of x with respect to x, cosine of x will become sin x plus c, and if we want to integrate sin x dx, then going around this direction we'll get minus cosine of x. So those are two basic results that you need. But what about the integral of tan x? We need to also know all of the standard trig ratios and their differentials, but there isn't one that gives you tan x. So for that one, for example, we need to write it as the integral of sin x over cos x. And then we need to notice that the differential of cos x, well, is minus sin x, so it's almost the differential on top of the function itself. And when we have the differential on top of a function, that's going to be a ln. So if we have the ln of the cosine of x, okay, if we differentiated that, so if I just do that over down here, so if we say y is the ln of cos x, okay, then dy by dx would be cos x on the bottom, and the differential of cos x, which is minus sin x, on the top. So you can see that's almost what we wanted. The only thing we didn't have was the minus, so we need to put a minus at the beginning there. So the integral of tan x is minus the ln of cos x. We can also write that the ln, using our log rules, of cos x to the minus 1, or the ln of sec x. Okay, so that's one type that you need to know. Okay, now the next type we're going to look at are the types where you've got cos to the power n of x multiplied by sin x, or the other way around, so sine to the power of nx times by cos x, and you're integrating those. Now they look horrible, but they're actually quite easy. So let's just do one example of that. So let's say the integral of cos cubed x sin x. Okay. And why they're easy is because if we use the chain rule, if we make a guess at something and then use the chain rule to differentiate, it comes out quite nicely. So what it makes sense to guess there, let's try over here, is y is the cosine of to the power of 4 of x. Then if we differentiate that, okay, we'd get 4 lots of cos cubed x, and then we need to multiply by the differential of cos x, so we've got minus sin x. Okay, so altogether we've got minus 4 cos cubed x sin x, which is almost what we wanted. The thing we need to do to adjust it is to just divide by the minus 4. So our answer to that integral is minus a quarter cos to the power of 4 of x plus c. If you needed a reminder of the chain rule here, if you think of this as, say, y equals u to the 4, where u is cos x, and then find your dy by du and du by dx, that should help you if you're a bit rusty on the chain rule. Okay. Next type we're going to look at are odd powers of sin x and cos x, integrals of those. So let's do a fairly straightforward one. So the integral, this time, of cos cubed x. Okay. Okay, so dx. So what we do with these is we write them as cosine of x multiplied by the cosine squared of x. Okay, and then we use our C2 identity for cos squared x, so we're going to replace cos squared x by 1 minus sine squared x. Okay, now that looks like it's making it more complicated, but it's not. So then if we multiply out those brackets, we've got cos x minus sine squared x cos x. And then the first part, integral of cos x, is nice and easy. That's just sine x. And then the second part of the integral, sine squared x cos x, is of the type that we just did. So if we're going to integrate, I'll just do this one on its own, sine squared x cos x, okay, we would make a guess that y was sine cubed x, differentiate that, and get 3 sine squared x cos x, which is almost what we wanted without the 3, so we need to put minus, because we had a minus in the question, a third of sine cubed x plus c. Okay, so if you wanted to do powers, say for example cosine to the power of 5 of x, what you'd need to do for that one is to write it as cos x and then cos to the power, or actually cos squared x squared. So that's how you go about doing that one. So, okay, when you do some harder ones of those. Okay, so next lot we're going to look at integrals of even powers of sine x and cos x. So for example, the integral of cosine squared x dx. And for either even powers of sine x or cos x, what we use are the identities for cos 2x. And if you remember, you've got 3 versions of that. But we're just going to use 2 versions of it. So the first one we're going to use is 2 cos squared x minus 1. Okay, if we rearrange that, we'll have 2 cos x plus 1 is 2 cosine squared x. So cosine squared x is going to be a half of cos 2x plus 1, and that's what we're going to integrate. So we replace our integral with cos squared x, put the half outside because that's just a number so we can, and we've got cos 2x plus 1 that we need to integrate. Okay, so leaving a half outside, if we want to integrate cos 2x, well, I'm going to guess it's sine 2x, and then I'm going to differentiate that. If I differentiate sine 2x, I'll get 2 cos 2x, so to integrate I need to divide by that 2, and then if we integrate 1 with respect to x, we get x, so the answer is a quarter sine 2x plus a half x plus c. Okay, so if I wanted to integrate, for example, sine to the power of 4 of x with respect to x, then I'd use my other identity for cos 2x. So that's a half of cos 2x minus 1. And because it's to the power of 4, and that's just sine squared of x, I'll square it. So you do have to multiply that out and then integrate each term individually, but it is possible. And these do come up quite often, these even powers, and once you know that technique of always using your identities for cos 2x, they're not really that hard. Some of them do take a bit of time, that's all. The last type we're going to look at of trig integrals for today are the integrals of the type sine ax cos bx, or it may be sine ax sine bx or cos ax cos bx, but where you've got 2 different numbers of x's, this technique is useful. So I'm going to start off with just one example, and then hopefully you'll be able to apply it to more complicated ones. So if we have, for example, sine 3x cos x. Okay, so what I need to do for that is to use my addition rules for, let's start with sine 3x plus x. Okay, hopefully you remember that is sine 3x cos x plus cos 3x sine x. Okay, you also need to write out sine of 3x minus x. Okay, so that will be the same thing but with the opposite sign. So, and then what we need to do is to look at what we want, which is actually this term. And if we add the 2 of these together, we'll get, on the right-hand side, 2 lots of sine 3x cos x. And the second terms, because one's plus and one's minus, when you add them, they disappear. So on the left-hand side, if we're adding these 2 terms, we've got sine 3x plus x is 4x, and 3x minus x is 2x. So instead of integrating sine 3x cos 3x, we're going to integrate a half, because we had a 2 here, so that was almost what we wanted but not quite, a half of the integral of sine 4x plus sine of 2x. And both of those integrals are fairly straightforward. So Okay, so we've got our, our half, and the integral of sine 4x would be, if we differentiated cos 4x, we'd get minus 4 sine x, so we need to put minus a quarter in front of that one, then we get the right thing. And then for the integral of sine 2x, we'll have minus a half of cos 2x. Okay, so just multiply that out. So we've got, and they're both negative, so it doesn't matter. So minus an eighth cos 4x minus a quarter cos 2x plus c. Okay, so if we wanted to do one of the types, say, the integral of, let's say, cos 5x cos 2x, what you need to do there, because we want a cos and a cos term, is to do cos of 5x plus 2x and cos of 5x minus 2x. Okay, and then you need to, once you've expanded those, you'll see whether you're going to add or subtract them to get something very similar to what you want to integrate. Okay, now as I said at the beginning, there's many types of trig integrals, and you really will need to do lots of practice on these, and I'm sure you'll get plenty in class.